First and foremost, I wanted to make sure that everyone at home knew who I was. So my name is Tom Hollingsworth. I am CCIE number 29213, and I used to be a CISSP. I let that one go because it turned out that I wasn't doing as much in that area as I should have. But there are a lot of great people out there involved in the CISSP community. My friend JJ Manila is part of ISC Squared, and I know that she's really doing a great job. But the other thing that I do now is that I'm the event lead for Security Field Day here. And so I get to talk to a lot of security folks around the community, and I get to learn a lot about what they're doing. And 12 of them just happen to be joining us today. And I'd like to take a quick moment for each of them to introduce themselves. Starting with Mr. Ben Mason.
I'm Ben Mason. I've been in the security industry for absolutely way too long. That plus on the other side of 20 is getting too long. I've been deploying, thinking about architectures, taking apart security things for a very long time. Super interested in discussing the topics today and being part of Tech Field Day.
Good morning. My name is Bruno Wallman. I'm been a network architect for a really long time, and more recently a network security architect, and glad to be here. You can find me on Twitter at @WallmanBruno.
Hello, my name is Edward Haledke, and I'm a virtualization, cloud, container security architect. And I look at all things platform is really what I look at. If it's a cluster, if it's a platform, I'm looking at how to secure that.
Hi, I'm Justin Warren. I'm the founder and chief analyst at consulting firm Pivot9, and my research interests are enterprise data center and information security.
Hi, I'm Karen Lopez. I'm Data Chick on Twitter. I'll be tweeting a lot during these things. I'm a data evangelist and architect who specializes in data security and InfoSec, and really looking forward to today.
Hello, my name is Kristen. I live in Germany. I run my own magazine, and I'm focused on network and security. So I started my career with telecommunications, was in high security branch later, and since 10 years I'm a freelancer, working also in tech marketing for tech companies, B2B only. And yeah, brand new, started a career as an analyst for GigaOn a couple of weeks ago. So thanks.
Hi, Michael Korsgaard. I'm a technology architect running infrastructure, mainly server storage and virtualization.
Hi, everyone. My name is Rati, based in Tbilisi, Georgia, working for the system integrator as a senior network architect. Currently focusing on enterprise and data center network technologies, but security is taking a big part in my role as well. And yeah, you can find me on the Twitter with the Pakistan username.
Hey, I'm Remington Luce. I work for VAR predominantly in the southeastern United States, and I help customers design and build network infrastructure and security deployments in that kind of same general area. And I'm on Twitter at localpref.net_net. Sorry.
I'm Scott Driver, 20-year IT vet, mostly in infrastructure and virtualization. You can find me on Twitter at VT as in Vermont, Snowboarder42. Happy to be part of my first security field day.
Hi, I'm Tony Afontis. I'm a CCIE and also a network forensic analyst. And I specialize in deploying network architectures and security architectures.
Great. And as mentioned, we do have a special guest joining us from EfficientIP. Alex, would you like to introduce yourself?
Yeah, thank you. Hello, everyone. I'm Alex Chauvin. I'm based in Paris, working for too long as most of you in this industry, and taking care for EfficientIP of the product between marketing and product management.
But I want to go ahead and get everything kicked off with just a little bit of an overview, because as we've learned over the last, I don't know, months, years, DNS is very important. It's the backbone of the way the internet works. For those of you old enough to remember what a phone book looks like, it is the phone book of the internet. And I know this because when my parents or my non-technical relatives call me every day, when they're like, hey, I can't get to this website. And I'm like, well, can you type this address in? Well, that's not where I'm supposed to go. Okay. Yeah, I'll look at it. Thanks. Because, well, the fact that it's always DNS is a meme now should tell you exactly how important this is. But is it always to blame? I think back to the recent Facebook outage where immediately everyone was like, oh, it must be DNS. And it wasn't DNS, but it kind of was DNS, but not for the reasons that you think. But it's that DNS is so critical to the way that everything operates that we absolutely have to consider it not only as a critical piece of infrastructure, but also how do we secure it? Because there are a number of ways that you can use DNS as a vector for an attack that won't actually be the fault of DNS. It's just a delivery mechanism. And there should be a lot of things that we're capable of doing in order to improve that, not just from the technology standpoint, but also from the teams and personnel standpoint. And those are the two things that we're going to be talking about today. So on the first topic of improving DNS security, I think I just want to toss out the big question. How can we help improve DNS security? I want to open this up to the panel right now. What are some ways that you think that people are not addressing DNS security properly that they absolutely should be, as we look at all of the ways that things like ransomware and crypto lockers and all kinds of nasty malware are leveraging DNS, hijacking DNS, causing us to do or to have to fight fires that honestly are totally preventable?
You almost need a DNS specific firewall.
Okay, so how would a DNS specific firewall work, Edward?
Well, for example, what I do is I force everything through one of my own DNS servers that on either side controls what can and cannot go into it. So it has a DNS entry point which says I'm only going to accept DNS requests of a certain type. Anything else will be blocked. And then on the other side, it's the same thing, so that if someone does try to exfiltrate data, it will never happen.
So essentially, you're analyzing the DNS request to make sure that they're valid and on an allow list.
Correct.
And if they're not, then they're getting out. Now, I could totally see that preventing, I think this is something we talked about earlier this year. There's a specific kind of attack called oil rig that allows you to exfil data in DNS requests because they're UTP in the clear. And so who does packet inspection on a DNS request? Because all it is a name. Well, no, it's a text string. And so that's absolutely something that you could do. But the question that I have, and this is something that seems to always come up, is scalability. Does that scale?
For my small environment, yes. For bigger environments, you need a lot more horsepower. Absolutely need a lot more. You probably want to use that as a detective more than a preventative in the large scale environments. But you also have DNS entries for things like SR services, which will be text, right? You need to know where your data is going. So for example, I'm basically saying any from inside my network has to hit this DNS server and only this DNS server. Once you hit that, then it passes traditional DNS on to the next hop. I'm also using DNS over HTTPS only exclusively, so that I'm also encrypting the traffic so no one can use it on UDP, for example. I just block all that outright. So this traditional exfiltration methods can be blocked and changed, but they still use it. You have to know what you're looking at, and that analysis is extremely difficult in some cases, especially if you're dealing with services. Even the email blacklists are done through a DNS query, a reverse DNS kind of. You query for the IP address to the blacklist, and it sends back a score. You still need to do that. It's still a valid request. So you need to know all the different valid and invalids and make it that way.
I wanted to take a step back. I think before you can know what methods there are to protect, I think you need to know the attack vectors that you're trying to affect first. We talked about one being data exfiltration and the DNS firewall being able to fix that. Another one is, having blacklists for certain websites that people shouldn't go to, DNS queries that are of known bad websites that should be blocked, things like that. So, knowing what you're trying to protect, having a list of bad ways that people can can attack DNS is important first.
I want to mention it's important to be able to have these deny and allow lists, like you said. But again, scalability. Going all the way back to my practitioner days, that was the easiest way for me to keep kids from going to Facebook inside of a school when they went to this HTTPS always thing, was to just redirect facebook.com to something like, I don't know, fisherprice.com, which, by the way, got really hilarious looks. But that only works in one specific location. So you would almost have to build your own architecture on top of it in order to make it work for, I don't know, like Boeing, where you can't just, constantly add little bits and pieces in there to fix that. You'd almost have to, it's almost like a certificate revocation list. And we all know how well people use CRLs, right?
I think that depends on the organization. But going with what Bruno said, that allow and deny list is constantly growing and changing. It could be days, it could be hours, it could be minutes when you have yet another blacklisted site show up. Who decides that, and how do you get that in to where everybody should be? That's
if you're trying to maintain that manually, that doesn't scale at all. It's you almost need to crowdsource it and subscribe, have a subscription service where you're subscribing to known bad websites, or having the intelligence in there. You get a drop file on your workstation. It's now trying to go after connect to random DNS connections. There's got to be a subscription service to help with that randomization and pick out that randomization, rather than having specific websites be blocked. There's an element of crowdsourcing, there's an element of automation, and an element of intelligence built in there.
This is Tony. I'd like to jump in and say that securing DNS and how do we improve it, there isn't a silver bullet, right? There isn't one answer. And I think that's what we're discussing here, right? With this roundtable, it's not a war with a single front that has a single solution. It's a war on many fronts. Like I think Bruno said, in order to understand how to secure it, you have to understand what are the attack vectors. And each attack vector has not a 100% solution, right? But has various ways to solve it when you talk about DNS as a command and control or as an exfil mechanism, right? We can mitigate that by inserting ourselves as part of the DNS infrastructure, having everything resolved locally so that you can have those inspections and protections. I think I heard someone mention about DNS over HTTPS, which is a great way to secure your connection to your DNS server, to make sure that you are talking to the DNS server and that the information you pass back and forth is encrypted. These are solving two different problems. DNS, as we know, has been around since the creation of the internet, just about, and is typically over UDP 53, which is a clear text protocol. And one of the things that I find most interesting is there's a ton of visibility you can extract just by sniffing traffic off the wire, looking at only DNS. I recently gave a talk at SharkFest about how I used this technique. I actually sort of hijacked a DNS domain locally and redirected and actually returned an A record to an IP address that I controlled, so that when someone went to a website, they actually went to a website where I was hosting something. This was a part of an experiment. And so I think the point is that there are, this is a war on many fronts, and there are many different ways to solve each one of them. And I'm not going to say solve, because every time you think you have something solved, there's a different way to get around it, to get through it. But there are different solutions that can be applied to the different fronts, and I have yet to see a single silver bullet. So again, understanding the problem is one, and understanding what you intend to protect is another.
So I want to jump in real quick, because I actually want to let Alex have a chance to speak on a couple of these topics, because it dawned on me that some of the things we're talking about with these allow lists and being able to block certain queries kind of lines up with some of the technology that EfficientIP has been working on. So Alex, what are your thoughts on this?
Yeah, so I agree with everything that I've heard so far, for sure. want to emphasize the fact that effectively we have a scaling issue to solve when we are dealing with a list of any kind of for any kind of policy like allow or deny, and this is something for sure we are working on. What our thought on that is effectively we need to try to solve a lot of these issues regarding whether the DNS is used as a vector or as a target. We mainly talk about the vector here and not the target, but we know that if we attack a DNS server and we can break it because of a problem in the code, and we know that we have something like almost 10 per year roughly main issues. We can tear down a whole infrastructure. We have seen that with Facebook, even if, like you said, Tom, it was not the DNS problem in that case. So we are working on. We try to work on all these aspects of the performance, the scalability. We can build on our solution list with millions of entry. In fact, we can put the whole registerable domain into a list in our system. So that's quite fun. And also something we haven't yet discussed about is, do you think there's an interest into applying different policies to different kind of clients? I would like to hear maybe your thought on that.
Hey, this is Remington. I was going to jump in for just a second to say on the client's part, maybe I might ask you to clarify your thinking, but you're right at what a comment I was going to make around the scalability and trying to resolve scalability potential concerns in DNS. You know, in a lot of security related efforts, you try to find a choke point and apply some form of policy or control in relation to the traffic that's flowing through. DNS has that in the form of servers that you're going to resolve. So you have a natural choke point that provides you with some ability to gain control, which is awesome in DNS, but you also still have the endpoint, which is going to go into the question you have around clients. At least I think that's where you're headed. And so, I mean, there are certain products that I'm aware of that you deploy an endpoint agent. There are a number of related, applications either on mobile or otherwise that essentially bypass the built-in operating system stack, if you will, and they use their own DNS mechanisms to ensure that they have integrity for their piece as well, or to make sure that they're not getting hijacked in the middle. So maybe if you could clarify, do you mean clients in terms of applications deployed locally onto endpoints or something else?
Yeah, that's a good point. My thought was more on does it make sense to apply different rules or policies like allow or deny based on the destination to various clients on the network? So like we do parental control on some ISVs, for example. We are working on that for enterprises as well, and we do see some interest. But I would be interested by your thoughts on does it make sense to apply to population A some filtering policy and to population B some other filtering policies?
So I think that
absolutely
makes, yeah, right. I think it makes a lot of sense to me from that perspective. Thinking of, I've seen use cases for DNS as content security. So just like you mentioned, let me filter out certain content for certain for my enterprise, for example. I don't want to have gambling, other kind of not safe for work content. I think it makes sense to have that as a capability in DNS services, and also to be able to provide nuance within that sort of capability. I've seen a lot of technologies utilize that functionality already, and being able to provide more nuance, especially in the content filtering space. Policies vary depending on departments and groups within an organization. So I can imagine that makes a lot of sense to distribute that and be able to allow that same capability in DNS, which I think is a great protocol to provide that sort of functionality within as a tooling perspective, and also have that visibility. I think I come back to a lot of the discussion I've heard so far about having visibility and analytics within DNS tooling, I think, is a key feature that needs to be in all DNS infrastructure, because visibility allows you that ability to see what's happened, who did what, how did it get there. And I think that's I think almost critical to DNS infrastructure and providing security and just intelligence into what users and teams and tools and bad actors are executing on infrastructure.
I'd like to challenge some of these thoughts coming from a predominantly American audience, which is, it's kind of interesting to me, because if we think about things like, for example, you're saying that we don't want anyone in this network to be able to look at gambling sites. And I would suggest that, well, perhaps, why are we using DNS to address this particular issue, which is that apparently we have staff who are looking at gambling sites when they're supposed to be doing their job. That to me sounds like an HR problem, not a technical problem. Also, a lot of this is like even the telemetry type things of essentially spying on all of your staff. So in some of these cases, what people are talking about, if this was your government doing it, I assume that the land of the free would be quite against this kind of idea. So a lot of what security does is quite authoritarian. And I worry that we have technical people who are making decisions about what the human beings can and can't do in their organizations, which is quite restrictive. And we wouldn't accept that kind of thing in any other part of our world. So the threat for some people could actually be the security team, because you're preventing me from being able to communicate with people that I need to be able to. So what the company views as a threat, I as an individual may not, or the other way around. So I think we need to be a little bit careful about prescribing these quite authoritarian solutions to what aren't actually technical problems.
So Justin, I'm going to challenge that one as well. What I want to know is, okay, running a company in the US, you're absolutely right, that could all happen. And that's neither here nor there what I'm going to talk about. Knowing the visibility of your DNS requests that go outside of your company are incredibly valuable, because that is exactly what your ISPs can see. That's exactly what the governments can see. Third part, basically in your country and outside. It's everything the hackers can see. So knowing that sites are visiting gambling sites, for example, or people are visiting gambling sites, opens you up to blackmail. So knowing that you have this going on is a chance for you to know if you're blackmailable or not. You're going to see what all these forensic hackers are going to see. So that visibility is incredibly valuable. What you do with it, now that becomes either political or legal, but the visibility is not going to hurt you. I would rather have that visibility because, for example, your ISP, regardless of who you are, where you are, is going to use your DNS queries to advertise to you. Is that good or bad? It's neither.
That's up to me to decide. I'd say. So that's part of what I'm suggesting is that who is deciding what is and isn't acceptable. So what should go on a not safe, the not safe for work list, like is looking at a site that provides union information. Is that good or bad? Well, for me, who is interested in perhaps joining a union, I might be quite interested in looking at that. You as the organization, perhaps you've decided that, no, we don't want any of our staff looking at that. Outside of the US, there are quite different attitudes towards individual employee privacy as well, and how far an employer is or should go with some of this. And I think
that's a false sense of privacy, because literally once you get on the internet with a DNS query, you have no privacy. Every DNS server is going to be able to see that. Anybody that has access to those DNS logs will have that information. It is a case of your DNS query is not private. Full stop. Don't even think it is, because UDP 53 is scannable and Anybody can get it. So if you want to prevent your ISP from seeing your DNS queries, don't use your ISP's DNS and encrypt the traffic to your final DNS service, whatever that is. But know that final DNS service is also doing the exact same thing. So if you think you have privacy on DNS, you really don't.
So we are talking about how we can improve DNS security generally, rather than just saying, well, this is the way it is, so nothing can change. That's what I'm pushing for, is that, well, what if DNS was private? And there are lots of efforts to actually make that happen. Now, there's a lot of pushback from security folks because of exactly this. We're saying, but that means that we lose the telemetry data. So some of the pushback with DNS over HTTP, for example, has been because it makes DNS opaque. And as people have pointed out, it is actually quite useful when you're trying to do security things. But what if that capability goes away, essentially because people have shown that they cannot be trusted with it? My ISP is hijacking what I'm searching for and using it against me. So when that happens, we have this dynamic tension essentially of an action and a reaction to that. And I think we need to get ahead of ourselves a bit. If we're looking at how do we improve DNS security, if we just do X, was like, well, what is the reaction to X going to be? What will that lead to? What new problems are we going to create when we make these changes?
All you're doing is when you deal with something like DNS over HTTPS and you're doing it inside of your network, that's one thing. If you're doing it outside your network to another, bypassing your ISP or bypassing everybody in the chain between your ISP and your final landing location for DNS queries, all you're doing is pushing your trust around. Instead of trusting your ISP, you're pushing it to whoever is the owner of that DNS over HTTPS server. Now, some of those DNS over HTTPS services will never look at the logs. We don't log anything. I'm not sure I trust that either, because they have to in order to debug problems.
If I could jump in here for a minute, we did discuss DNS over HTTPS as a specific solution to some of these problems in the last panel that we did earlier this year, which, by the way, had a ridiculous amount of viewership on the video. I was very impressed by the number of people who were interested in the topic. But I think one of the problems that we tend to get bogged down in, and I think that this is because we're technology people first, is that just like a carpenter, the solution to my problem is another tool. I don't know if I can build this house any better, but if I only had that planer joiner radio tool made by DeWalt, I could fix this problem faster. Except, can you? Or is the real problem that you're building a house that has no right angles? Well, that's a process problem, not a tool problem. And I think that in IT especially, we tend to get overly focused on tools. And I know I say this with Alex sitting in the session and he makes tools, but I also think that Alex would be the first person to agree that we need to come up with a variety of solutions that secure a number of areas of DNS and secure things other than DNS. Because when DNS is the only tool in your toolbox, then every problem looks like a block list, or it looks like a redirect, or it looks even like something more complicated than that. And that focus tends to make it a lot more difficult to secure the entire organization because, and I'm sure this quote's been going around quite frequently, and to properly attribute it, it was the IRA speaking to Margaret Thatcher in the 80s. You have to be lucky every day. We only have to be lucky once. And that's how the attackers are. You can secure everything in your organization, and all they have to do is find one hole. Karen, you had mentioned that you had some thoughts around this. I wanted to give you a chance to jump in here.
Yeah, so I'm listening to all this and thinking, I mean, I kind of have this ongoing rant about we need to, when we innovate new things for the internet, we need to involve many more pessimistic, skeptical people. Like we keep designing these wonderful new things so that people don't have to memorize IP addresses or mail server names and all this other stuff, but we always design it to optimize for good people doing great things. Instead, we should design everything new that assumes that the entire internet is made up of bad actors doing bad things, And really, I don't mean hackers, I mean people who want to exploit it to make more money for themselves. So I think about the times that early on when I got my first internet provider, and one of the first things they did was started via their DNS stuffing and changing search results and hiding search results from, say, Google or whatever search engine I was using at the time. And that shocked me. I mean, I came to that realization. We learned this lesson over and over again. We learned it with email. Email was designed saying people should be able to send millions of emails to anyone they want. That would be so great. And then we learned. So when I think about what should we do to fix the security of something designed in an overly optimistic way, I think we need fewer optimists. And I'd love for someone to disagree with me on this.
Who wants to
I don't
disagree with
disagree.
the pessimist?
I don't
I
disagree.
don't necessarily disagree with you, Karen. I started emphatically shaking my head because I think not just pessimists, but I think we need to broaden the pool of who's participating. It shouldn't just be large enterprise or researchers. We need to understand the needs of the little people as well as the big people if we're going to democratize these technologies.
And also try to see how someone trying to leverage more money for themselves would abuse it. Like, it's not just people wanting to take down your sites. It's people who just want to stuff ads in front of your face or get their company name in front of you. That, like, those are annoying as well. Or governments trying to hide essential information about what's going on in the world. Like, it's not just white hat, black hat. It's your business partners, your government, your vendors who might be trying to do things.
So Karen, the democratizing of everything is great. I like that idea, but the problem is specifically around some of these protocols is that they are being used to just make money. They've gone the other direction. It's not a democracy. It's not freedom. It's about capturing the data to make money on it. And DNS is one of those ones that is incredibly easy to capture, incredibly easy to monetize. And that, to me, is why, in some cases, I use something like DNS over HTTPS, so I can push it past the people that want to monetize. Now, eventually, I'm going to have to trust somebody because I need a DNS response. But is that where we should be going with DNS and other tools of that nature? Or should we just say, don't make it so you can't monetize it in the first place? So the whole privacy question comes into play. This stuff is not private. Someone somewhere is looking at it, either by machine learning, or by human. How do we protect our privacy when all that's happening?
I think there are kind of three layers that are stacking up right now in relation to the security, because in security, it's always important to talk about layers, right? So you have the actual, improving DNS security, you have the actual physical transport or the protocol behavior itself, right? And then in the case of DNS and the way that it's working, we're talking about the content that's coming through it and the interesting and exciting ways that you can abuse that particular content, either to exfiltrate data, to change what the request information that comes back to you is and use it to poison and redirect traffic. And then on top of that, the conversation right now to me is sort of focusing on the privacy component that comes out of DNS and what you can take what someone is doing and what they're requesting to see. And you have that because of the way the DNS works with a specific name, right? And the services that are tied to it. You're now kind of discussing the privacy component of that security. To go back to the question that started this all off, right, Tom, is, there are tools that can engage in each one of those layers. And to something that Tony said earlier, there's not one piece of this that comes out, right? There are things that we can do to try to actually harden up the protocol and the way that it's going to function. There's things that we can do to try to ensure that the content coming back is accurate and that it's not something other than what we want it to do. And then there's a whole other layer of things that are around who gets to see it, who gets to control it, and who gets to change it. And I don't really have an answer there, but just in my mind, that's how I frame up DNS security. And each one of those has a visibility component and each one of them has a control component, right? So it's interesting to hear other people talk through how they see that and which part of that stack is kind of the part you jump to first when you talk about DNS security.
Remington, I think that was an a really awesome way to sort of break down, I like the layers approach. I thought that was really cool. I am a technical person. I love the protocols, so I always go to the technical solutions for the technical problems, at least from my perspective, how I see them. And I am not the first person or the correct person to be talking about what I'm about to say. But what if we made, like at a governmental level, what if we made making profit off of DNS requests illegal? You know, what if that was actually illegal and ISPs, DNS providers, midstream providers weren't able to make a dollar a dime off of it, and we also made it illegal to share that information with anybody else? Would we even bother with these other technical implementations then?
Tony,
Yes.
that would make the entire internet impossible.
Mhm.
Because technically, there's no way to technically block them from ever being able to do that. Just by sending you to a site, a store site, let's say, whatever, pick your favorite store site, that is making money off of DNS, technically.
I would also argue that if you make it illegal in the US, you just move the activity somewhere else. And Sealand still has a server closet, from what I understand, and your laws no longer apply in the Republic of Sealand. But there's a variety of ways that you can attack this particular problem. I do want to wrap this discussion here because I do have another topic that I want to make sure that I bring up. But I will tell you that the fact that we went over the allotted time for this should tell you exactly how thorny this particular problem is. And I would love to hear the thoughts of the people in the community. If you want to, write up a tweet storm, do a reaction video, you name it, I would love to hear what you have to say.